Hello, everyone. My name is Eyal Weiss, and I'm a PhD student in Bar-Ilan University, working under the supervision of Professor Gal Kamenka. My research is about a generalization of automated planning using dynamically estimated action models. So we know that AI planning is a mature research field. Decades of research have led to planning capabilities which are solid and that include sophisticated search algorithms, various domain-independent heuristics, which are efficient, planet portfolios, and more generally, planners that are capable of solving difficult planning problems. Yet AI planning is still considered an academic niche, at least from the perspective of usage outside of the research community. Our main point is that simplistic models are a true inhibiting factor for widespread usage. So let's give an example. So we consider the transportation problems which were introduced in the international planning competition in 2011. So these problems have three actions: pick up, drop off, and drive, where drive actions are the interesting actions which have a varying cost, okay? And we can see that the cost is calculated using a simple formula that basically includes the road length between two points. So clearly commercial solutions use many more parameters in their calculations, right? These include, for instance, flight weight, drive time duration or estimated duration, lately also carbon emissions. We know that insurance compatibility is important, and all these factors and more should be considered in the computation, okay, which is clearly more involved than the one done here. Okay, so we also know that commercial solutions use estimates, okay, rather than exact values. And these estimates quantify numeric uncertainty, which is many times inherent in the calculation, okay? They are basically unavoidable. So we also know that in terms of planning, ground actions, okay, have different estimators, okay? So not like here, not action templates, but ground actions can have different estimators, and these may consume runtime, which might be non-negligible or even considerable, okay? Additionally, we may have for each action more than one option for estimating its cost, okay? So this is something that planners should know how to deal with. So our observation is that current planners rely on fixed modeling choices, okay? So these are apparent either through explicit declared action templates, which basically represent the declarative approach, or by a mixed declarative procedural approach using semantic attachments, which are models that have return condition checkers or effect applicators. Okay, so they can be combined with declared models, or a full procedural approach, which is basically to turn to a simulator, which gives access to implicit action models. Okay, so this approach of using a fixed modeling prior to planning introduces two bottlenecks. These bottlenecks are early commitment to modeling computation and early commitment to modeling choices, which are linked together strongly. Okay, so let's say we want to consider a large planning problem. So we might pre-compromise on the accuracy of our models, since we want them to have low computational overhead, okay, if we want to be able to solve the problem. Alternatively, we can decide that we want a very high resolution, but this usually involves considerable runtime for modeling computations, okay? And this, of course, can be difficult. It can be an obstacle to solve difficult planning problems. Okay, and the result of this is basically inability to successfully tackle many realistic planning problems. Okay, so our approach, and this is a general approach, is to use dynamically estimated action models. This means that we offer to postpone all or part of the modeling to the planning phase, to give the planner control of the modeling component so that during planning, the planner can choose which model for each action it wants to invoke. And in order to give the planner some flexibility, we need to consider an acceptable accuracy for the plan. Okay, so the plan cannot be 100% accurate if we want to allow the planner some flexibility with respect to modeling choices. Okay, so the advantages of this approach is that it allows multiple resolution modeling. Since it enables to reduce computational overhead, it supports scaling to richer problem descriptions. It also natively handles inexact learned action models. So we know that many data-driven models have inherent uncertainty. It extends existing domain-independent planning capabilities. And lastly, it offers the chance to algorithmically balance accuracy versus computation time, which is a strong trait. The disadvantages, of course, is that it induces a harder planning problem. And this is something we have to deal with. So our first concrete implementation of the general approach that we've introduced is planning with online action cost estimation. So for this, we've introduced a novel planning definition, which considers the case where every ground action may have multiple cost estimators that return lower and upper bounds. Then the planner plans with cost bounds instead of exact costs. And the target is to find a plan which is suboptimal up to some specified suboptimality multiplier. For that, we've introduced an algorithm that generalizes A star for using these estimators, and extensive experiments done provide empirical support for the usefulness of our approach. We invite you to check out 2 papers that appear in the RDDPS workshop that give more details. Thank you very much.